Hi everyone, my name's Peter Shields and on behalf of Airmet Scientific, I'm pleased to welcome you all to today's webinar, Near Real-Time Multi-Parameter Environmental Monitoring and Data Capture. Today we have two presenters from Airmet, Peter Bernacchio, the Engineered Solutions Sales Manager, and Arnold Perez, the Senior Service and Engineered Solutions Manager. We will also be hearing a case study from Mr. Philip Hibbs, Principal Consultant from Hibbs. So I'll now hand over to Peter Bernacchio to start the presentation.
Okay, well, firstly, I'd like to thank everybody for taking the time to join us on this webinar. What I'll do today is I'm going to give you an overview of who Airmet is. I will also present our Airmet E-RAX. We'll talk about a couple of case studies and also touch on the reporting capabilities of the instrument. We'll then speak a little bit about where the product will go from here in terms of any product development. So most of you, I guess, know who Airmet is, but for those who don't, Airmet was formed in 1984. We're a proudly Australian-owned and operated company. We have ISO 9001 accreditation and also accredited for NATA. We have sales, service and rental capabilities in each office. We have 6 conveniently located offices in most major cities in Australia, and these provide local equipment, service and technical support via our qualified and experienced service techs. We also have experienced rental teams in each office, and they can assist you with equipment selection or your field work. Also, we have our in-house engineered solutions team, and we can assist you with designing and building any custom monitoring solution that you may have an application for. Here's just a few of the brands that we represent in Australia. A lot of these, of course, you'll be familiar with. SKC, Industrial Scientific, YSI and Oldham, amongst many others. Airmet is also very proud to work with a range of small, medium and large companies. And of course, these include such companies as Hibbs, the Department of Defence, Department of Transport, and also ExxonMobil. All right, I'm now going to introduce you to the Airmet E-RAX. So the E-RAX is a near real-time, compact, and very easy to install air quality monitoring station. A modular design allows the unit to support 1 to 7 gases, including high and low range CO and CO2, PM10 and PM2.5, general weather conditions, and also ambient noise. The E-RAX is housed in a weatherproof IP65 rated polycarbonate enclosure and makes it ideal for outdoor monitoring. We have data logging capability a minimum of 365 days at 1 minute intervals. The unit also has a built-in log and forward capability. So this enables you to capture up to a week's worth of data should or in the event of a network disruption. Also, the unit will integrate seamlessly with our Airmet Scientific's web-based portal. This enables the users to access your monitoring logs, also set customizable alerts, manage your monitoring reports. The web service application, of course, is available on any desktop, laptop, or any mobile smart device. Just some key features or aspects of the unit. It features a PM2.5 and PM10 sensor with a range of 0 to 999 micrograms per cubic metre. We also feature a high and low range option for CO and NO2 sensors, and that's amongst the range that you can see there of the various sensors that are currently available. We can also integrate the weather station and also integrate a noise monitor if required. The AX is housed in a polycarbonate enclosure which only weighs 11 kilos. So it can easily be mounted on a pole or a tripod, so depending on what your application is. Because the instrument is made locally and assembled locally here in Melbourne, our customers will benefit from local service, also local calibration. So this is going to minimise your downtime and of course minimise the costs associated. So I'm now going to just touch on a couple of case studies. The first case study is a remediation site which is operating in Melbourne currently. I can't go into too much detail in terms of location or any other details because it does need to remain confidential. However, to give you an idea, our client's customer is in the process of digging up and removing heavily contaminated soil from a site that was once occupied by a chemical storage facility. So the concern from our client's customer was the potential migration of the contaminated soil due to the works that were being carried out on the site. They're worried that this may migrate into the neighbouring community and therefore cause a problem with health or problem for health and safety. So what was required was the monitoring of the 4 boundaries for VOCs and particulates. They also required a weather station for wind speed and wind direction. So this was a long-term project and will run for 18 months. And part of the requirement was very detailed and strict reporting back to the client. So after consultation with the customer, the E-RAX with a solar panel and weather station option was chosen. And the choice was to rent the unit for the duration of the project. And along with that, a very heavily customised monthly report to the end user specifications. This reporting minimised the time required by the consultant to interpret the data and therefore enabled the consultant to present the report directly to the customer. Now, the system was installed by our local technicians. It will require very little maintenance over that period of time. So in this case, it'll just be the exchanging of the particle counter after 12 months. The VOC sensor will require calibration every quarter and about every 12 months a filter change. And this of course can all be carried out by our local service teams. So I'm now going to hand you over to Phil Hibbs and he's going to discuss with you his experiences with the E-RAX unit.
Thanks, Peter. All right, good afternoon, everyone. For those of you that don't know me, my name is Philip Hibbs. I'm an occupational hygienist, although I've done a lot of monitoring over the years and used a lot of remote monitoring stations. But when I was asked to talk about the AirMetER AX, I was delighted to be asked because we've rolled this out on a couple of our sites now very successfully, and I was quite happy to talk about that. Now, the earlier presentation that Peter just spoke about with the use of the AirMetER AX for environmental monitoring applications of a contaminated site, but I want to talk about a slightly different application. The AirMetER is a very versatile system, and we've been using it for remote real-time monitoring of specific airborne contaminants on construction and infrastructure development sites, where we've essentially been using it as an indicator to assess control measures on those sites. For example, for particulate matter, it can be used to assist with assessing the efficacy of water suppression and/or extraction ventilation systems in dust control. Now, it's important to note that the data from the remote monitoring stations can't be assessed using workplace exposure standards because it doesn't measure personal exposure. It is measuring levels of contaminants in a general area in which it is located. Personal exposures for comparison with workplace exposure standards can only be estimated by collection of breathing zone air samples from individual operators. Now, the data collected from remote monitoring stations is used in conjunction with control action limits, and the control action limits may reference the workplace exposure standards in their development, but we're not measuring personal exposures. Now, the typical health hazards that may be encountered on construction and infrastructure sites, and certainly the ones that we've been working on at the moment, include respirable dust, respirable crystalline silica, diesel particulate matter and noise. And on former fuel storage sites, strata that's contaminated with volatile organic compounds may also be encountered during excavation works. Now, the instrument logs in real time and uploads to cloud-based system LiveSense. Now, they'll talk more about LiveSense later on. The unit can communicate with the cloud-based server either by the Telstra mobile network, Ethernet, Wi-Fi, and LAN. Now, where the Telstra network is available, but it's weak, the signal is weak, an external high gain antenna can be fitted. And in our application, we've been using all of these. So the LiveSense has a customizable display for managing and reporting the data, and we've also been able to set up control action limits that are indicated on the in LiveSense, and when those action limits are exceeded, the system notifies us, and it also sends the client either an SMS or an email or both. So in this situation here, we've got the system actually pointed out there. It's mounted on a tripod. In the previous slide, of course, it was mounted on a wall in a relatively small area where there was a lot of high activity and high dust generating activities. In here, we've got it mounted on the tripod, and it's actually, it's a little hard to see, but it is standing proud of the that column that's there. It can't be located right in the middle of all the action because it would be run over in about 5 minutes flat. So we didn't really want to destroy an instrument by running over it with a large excavator or something. So it's off to one side. So now the system configuration that we're deploying on our projects is particulate matter, PM10 and PM2.5, carbon monoxide, nitrogen dioxide, and a PID or photoionization detector for measuring volatile organic compounds. Now, we're using PM2.5 in the absence of NO2 and CO as a surrogate for estimating respirable dust. Now, it's understood, now before everyone jumps down my throat and says that respirable dust is more than just PM2.5, we understand that, but we are essentially using it as an aid to assist with notification when dust levels are high. And as the crystalline silica content of the strata is generally known in the materials in which we're working, the respirable crystalline silica content of the PM2.5 dust cloud can also be estimated. And then this is confirmed by parallel sampling using a size selective cyclones in accordance with AS 2985 with analysis for RCS by X-ray diffraction. The size selective cyclone is actually located directly adjacent to the particulate matter inlet on the AirMetER. And we're using PM2.5 in conjunction with NO2 and CO as a surrogate for estimating diesel particulate matter. Now, on the sites in which we're working, previous site contamination investigations have identified the primary VOC contaminants of concern. And the most common contaminant that we're encountering on these projects is petroleum products, and so that the PID is corrected for gasoline. Particulate matter, we've set it for RCS at 110 micrograms per cubic meter, and that's based on calculations using the workplace exposure standard, altered or reduced for extended shifts, and also the known and validated data for respirable crystalline silica, as we've collected it from both the strata and from airborne monitoring to confirm that. So there we go. As I said, the particulate matter at 2.5 set at 110 micrograms per cubic meter. That's based, as I said, on the level of crystalline silica in the strata, the shift-adjusted workplace exposure standard, and taking 50% of that. Now, I wanted to talk a little bit about some of the graphical output that we can get from the AirMetER, because it can be structured in a number of different ways. And Arnold will talk about this in a little bit more detail later on. But this is the raw data as it comes out, and you can see that this is for dust PM 2.5. And we've set our line at our control action level, the line in the dotted line, at it's actually at 110 micrograms per cubic meter, and this is the raw data over 1 minute averaging periods, and it would be very hard to tell, where you're exceeding and where you're not exceeding, because you're not interested in instantaneous exceedances. We're interested in looking at trends to see where the dust levels are rising, so that we can then alter our dust control activities to try and either suppress dust or exhaust it in some other way. So the next thing we are looking at is it's the same data, except the lower graph shows a 1 hour integrating period, so that it's an ongoing averaging over 1 hour. So you can see that drags the data down quite considerably and well below the action level we've got set there. And then if we can actually change that to a 1 hour integrating period and a 12-hour integrating period, and you can see that over these longer shifts, it's the dust levels are somewhat lower. Now, these graphs were a bit dull because they were all below the level. So we actually wanted to put a graph that was a little bit more interesting, insofar that over the 1 hour averaging period, this is the plot of the 1 hour integrating period. This is our action level here. So we've certainly exceeded at these points. So the way that we've set up the alarms, you can set them up in a number of ways. You can set them up on rising and falling. We don't need the falling, because we only want the rising. So it sends an email and a text message at these points where we exceed the action level. And at these points where it's been exceeded, interventions have been put into place on this site. It was actually increased water suppression to try and control the dust. Now you can see as it's risen up again here, and it drops dramatically at this point here. That's actually an 0600 shift change, but they did increase water usage and also exhaust dilution ventilation as well at this point. So you can see that where it's come down during the next shift. So, however, if we take that graph and we look at over the 12-hour integrating period, you can see at no time over the 12-hour integrating period did we exceed the exposure, what would be our action limit. So it's a reasonable assumption that people working in that area, that their exposures were being relatively well controlled through the interventions that we were making. And that's me for the time being. Thank you.
Good afternoon, everyone. So basically, this is our web service application. It is supported by the Android OS and iOS, and also any web server, like the Internet Explorer or any web browser for that matter for desktop application. So it can be, I mean, it's a simple dashboard configuration that you could do color coding on them, like on columns, to identify which are on alarm or above your exceedance limit. And also you could access them on supported devices. You could also view historical data on it by a line graph, and the graph that Phil actually showed on the previous slide. So the data and security, actually, the web service actually allow us to have hierarchical credential, like an admin, a supervisor or manager, and then a user, so that you could separate the accessibility of the web service. The data and security is being hosted in AWS in their Sydney server. So we make sure that the data doesn't live outside Australia, because some customer doesn't want it going outside the territory. And it's also an SSL SSH encryption during transmission, so it's secured. So basically, you could customize the reporting on it. We support a variety of graphs, like line graph, area graph, wind rows for other, like wind speed and direction. You could do a customizable report, and then threshold alert management via SMS and email as well. We're not yet done with developing the unit. Actually, we're in the process on working with the Department of Transportation to deploy the black carbon, or the particle size less than PM1, the ultraviolet detection for black carbon. We're very near on making that happen. We're working with the Department of Transport, as I mentioned, and also we'll be deploying vibration sensor alongside with the E-RAX by Q4 of 2021, and also the ultrafine particles. So we're continuously developing the instrument for other application, or for any application that you may have. And also the platform is so flexible. As mentioned, we have like high CO, low CO detection, because we can change the sensor within it. We're very flexible. At the same time, on the web service, if you have some special report, you require some modification in it, we can do that on the back end. I'll transfer the control to Peter Shield.
Thanks, Arnold. Thanks, Pete and Philip. If anyone's got any questions, if you'd just like to type them into the questions box. So far, we haven't had any.
I'll ask a
Typing's
question.
like mine and slow. Please do.
Yeah, Arnold, you said that you're developing the machine further, particularly in the black carbon, the less than PM1. What's the time frame for that, please?
So we're 80% done with it already. We might be able to give the Department of Transportation 2 units by mid of April.
Yeah, okay, because I'd certainly be interested in that as well.
Yeah, so basically what we currently have now is 100 micrometer. We want to go below that until 300 nanometer, so that we have the full range of spectrum on it.
Yeah, that'll make the equipment very versatile.
Yep, we're very near on it, and the Department of Transportation is very excited as well. I mean, we're working very closely with them, and hopefully we'll be able to deploy the first 2 units by mid-April.
Okay, well, it looks like there's no further questions, unless you've got another one, Philip.
Well, I'll ask another one then. Can you this with this other sensor that can be retrofitted into the existing units?
Yes, basically that's the idea behind it. The requirements for the Department of Transportation, they wanted a double wall and a temperature controlled box on it. So that's what we're trying to achieve. But
right,
the accelerometer will be inside the original AX box. So it's the same unit. If you don't require a double wall on it, then it will be the same size that you currently have on your field.
All right, and so the in the existing units, it would be sufficiently stable to run and operate then?
Yeah, we already tested the unit, the accelerometer. We have a successful upload and everything, but we wanna make sure that the unit will survive on Melbourne's summer. Basically, that's the whole system is already running. It's like we need to make sure that the system will survive on Melbourne summer at 43 degrees Celsius, basically.
Sitting in the sunshine.
Yes.
Good for your solar panels.
We have got a few questions now, so that one's covered. Peter Aspinall would like to know if there's any chance of making the batteries lighter. Thought a muscly bloke like him wouldn't be a problem for him.
Yes, absolutely, Peter, and hi. The units, the battery is a deep cycle. That's why they're very heavy. But we're currently looking on a lithium-ion version on it that makes the capacity almost the same and about a quarter of the weight. So, but the currently what we have in the market is the deep cycle battery.
Thanks, Arnold. Here's one for Phil from Julie Sullivan. Excellent info. Phil, would you mind repeating how you got 110 milligrams per cubic meter? Or micrograms?
Well, micrograms per cubic meter. Look, it might be better if I contacted directly, but just as a general rundown, the 8-hour workplace exposure standard for crystalline silica is currently 0.5 milligrams per cubic meter, or 50 micrograms per cubic meter. We have to adjust that because we're working extended shifts on this site, so we've adjusted the workplace exposure standard, and then we actually, from the data that we had, we knew that the crystalline silica content of the strata was somewhere between about 20 and 30%. So we initially set it at 25, using 25%, but then when we ran all the validation data by running parallel sampling, it's actually coming up at around about 18%. So when you put all that together, it comes up at around about 110 micrograms per cubic meter. But I'm happy to offline share the mathematics.
Thanks very much. Anthony Williams has said, when setting trigger action levels, is it possible to assess results relative to a background level if you have 2 units?
Who's that addressed to? I suppose all of us. Look, if you could probably put a second unit in a reference environment, I don't see why you couldn't do that. But essentially, what we want it for, we're not trying to assess exposure or anything. We're simply trying to assess the efficacy of contaminant control systems, primarily dust. But in an environment where it's impossible to completely control the generation of dust, and on large infrastructure and construction sites, there will always be some dust. And the concern, of course, in a lot of the strata that we'd be working on is respirable crystalline silica, and it is hard to control. So what we're using the system for is setting an action level, and then we're simply watching the graphs. And then if it's on the constant increase, then we realise that it's understood then that the dust control is not sufficiently. Well, the dust is not sufficiently well controlled, and we need to either look at further water suppression or better ventilation.
Thanks, Phil. Dusty Bennett said, well done, team. Can you please expand on the routine maintenance? Have you experienced any issues in high dust environments? That's probably one for you, Arnold.
So basically, how we deploy it, we already deployed a lot of unit, and it's true that when we receive an instrument, the filter is kind of, I would say, dusty because it keeps on collecting those dust. But the good thing is we provided a very good pump on it that can sustain a high back pressure, so it can continuously draw sample even though the filters has a lot of contaminants on it. So as mentioned previously, I think it's Peter mentioned, he mentioned about the maintenance. The replacement of the filter is kind of dependent on the application itself. If it's very dusty, it might need the replacement every 6 months or every 3 months. But on a normal scenario, we recommend replacing it every 12 months. Hopefully that answers the questions.
Thanks, Arnold. I've got one here from Carrie Ann Jessup, which is probably you again, Arnold. On a construction site, how easy is it to move it as the work front moves, such as in tunneling?
Yeah, good question. Thank you. I mean, we have application on a tunneling as well. They in Sydney, so for ventilation as well. So basically, the unit's 12 or 11, between 11 to 12 kilogram. It depends on your configuration, right? So it's very easy to do it, to move it around. You could mount it on a wall, or right now the highly recommended is using the tripod. You could carry the tripod by itself. With the tripod, it will around 20 kilos. So it's really easy to move around. The unlikely is the battery. If you have a battery support on, or you're powering it using the battery weighs around 35 kilos. That's why it was raised as a question to reduce the size and make it like effective. But yeah, it's transportable and easily configured.
Yeah, look, I'll add to that, saying that, you know, we've moved the gear around quite a lot, and it is easy to relocate it. In situations where you don't have access to, well, it's better if you've got access to 240 volt power rather than lugging a battery around. But in situations where you don't have access to the Telstra mobile network, you really need access to either Wi-Fi or a LAN.
Thanks, guys. Yeah, Dusty Bennett said, are you experiencing any interference due to water aerosols from suppression sprays?
Haven't seen anything at the moment, but it's a little bit hard to tell. We don't sit it right directly where it's going to be contaminated with water sprays. It is located a little distance from it, but it doesn't appear to be an issue at the moment, because presumably then you would see problems with the PID as well, and we haven't.
Yep. Yeah, you answered it pretty much spot on there, Bill.
Yep. Thanks, guys. Oregon Watson would like to know what are our options for getting this data out for ingesting into an alternative platforms?
So basically, the routing of data, we could do it. We have an open API. If you want to connect our data server to your server using an API, or if you have an application, for example, you want to get 3 units and you want to direct the upload directly to your server, and then you will do the parsing, we could do that as well. We could direct the upload to your existing web application, and or we could do both.
Thanks, Arnold. That looks like most of the questions now. A few thank yous in there, so that's great. Thanks very much, everyone. But yeah, so just in wrapping up, I'd like to thank you all for attending today. I trust you found it informative and interesting. If you've got any further questions on anything that was discussed today, please feel free to contact your local Airmet representative. Finally, thanks, Peter, Philip and Arnold, for your time today. Thanks very much.
Thank you. Cheers.